All right, let's say once again, I want the equation that goes with this graph. And we've done stuff like this before. Except one thing I think you'll notice in this particular problem is we would have to find the slope, which not too hard to find here. I can see the slope from point to point, the rise and run. But if you look right here, the y-intercept, it's hard to tell where it is exactly. They haven't given us a definitive point. It could be 3 1/3, 3 1/4. And of course, with mathematics, we need to be exact. And so what we find out is that slope-intercept form is not always going to be available to use. This won't work in this situation. So what somebody came up with was this idea that there's another type of equation called point-slope form, where the slope we still find. If you look here, we've got a rise of, looks like -1, and then across +4, so my slope is -1/4. But since I don't have the y-intercept, well, I can kind of see it, but I don't want to approximate. What I can do is I can just pull some random point. Like, for example, right here. This point is easy to see. It's 1, 3. And so what someone figured out was that there's another way to do this, that if we take the slope formula and rearrange it a little bit, we get this. This is what's called point-slope form. Y minus y sub 1 equals m times parentheses x minus x sub 1. And actually, let me change this here a little bit, because the reason why I've highlighted some of these parts in red is because these are the parts we're going to fill in. So m should also be highlighted because that's the slope. And so the idea is this, is that this equation is another way to write linear equations where it's y minus, and then whatever the y coordinate of the point is that our line goes through, in this case 3, you put that here, equals m, the slope, times parentheses x minus x sub 1, which was the x coordinate that our line went through, the point right here. So what I can do is, it makes it really nice. We just have to plug in numbers. Y minus y sub 1, which is 3, equals the slope, -1/4, parentheses x minus 1. All right, now, even though this is a convenient format to put the equation in, typically what we see is that we want to change this into slope-intercept form. So we do have some cleaning up to do. So we're starting off in point slope, but now I'm going to do distributive property here to make this -1/4 x, and -1/4 times a -1, that would be +1/4. And then to get y completely by itself, to get it in slope-intercept form, we add 3 to both sides. So I get y equals -1/4 x plus 3 1/4. All right, and there's our equation in slope-intercept after starting off in point slope. Okay, so this is another format which you want to have committed to memory. Y minus y1 equals m, the slope, times x minus x1, where m is the slope and x1 and y1 are a point. All right, now the question usually comes up, well, what if we had used a different point? Because as you can see, I've labeled 4 different points here. So here's the same graph, exact same graph, exact same slope, -1/4. Okay, but what I'm going to do here is I'm going to say, what if I had chosen a different point? Okay, wouldn't my equation be different? Well, yes and no. Let's use this one. I'm going to pick this point. So instead of picking this one like I did in the last example, I'm going to pick this one. So 5, 2. Okay, so I've got a point that my line goes through. I've got the slope. So because I was given those two things, I'm going to use point slope form again. All right, so let's plug the right things in the right spot. Y minus, and right here you should have plugged in the 2 because that's y sub 1, equals our slope, m, -1/4, parentheses x minus, and x sub 1, should plug in the 5. So this is a completely different equation from this one. So you might think, oh, I've got a wrong answer here. But here's why we put it in slope-intercept form. Because initially, these two equations look different. But watch what happens when I put this one in slope-intercept form. Distribute the -1/4. Negative times a negative is a positive. 5/4, which would be 1 1/4. Okay, I just did 5 times 1 divided by 4, 1 1/4. Get y completely by itself by adding 2 to both sides. So I get y equals negative 1/4 x plus 3 1/4. Okay, which, after rearranging it in slope-intercept form, that's the exact same answer we got on the last one. Okay, same line, same slope, we just used a different point, yet mathematically it's just kind of cool because even though it starts off looking different, when you put it in slope-intercept form to finish it off, you get the exact same answer. Okay, so that's point-slope form. It's this idea that instead of just always having the y-intercept available, you can use any point, you can find the slope, and if you use this format, you can still come up with the linear equation that goes with the graph, even when they don't give you the y-intercept. All right, here's another example. Again, let's try to figure this out using point-slope form. I've got a graph, and again, what's troublesome here is that the y-intercept, it looks like it's at 2.5, but it can't quite tell. It could be 2 3/5. We're not quite sure. Okay, so what we do is we find some good points, the points that line up nicely with the grid. So here's one. 1, 3 is a good point. I'd say here's another good point. Here's a third one. Okay, we just need enough where we've got a couple to choose from. So let's do what we know first. Let's do slope. Looks like we've got a rise of 1 and a run of positive 2. So positive 1 and positive 2, slope of 1/2, rise and run. Now, just like in the last example, you can pick any point you want. So it doesn't matter if I pick this one or this one or this one, as long as you pick a point that's on the line. I'm going to go with this one, 1, 3. Okay, so we pull out point-slope form, and we just plug our information into the relevant spots. Y minus, in this case 3, the y-coordinate, equals the slope, which is 1/2, times parentheses x minus the x-coordinate, which is 1. And again, because if we had picked a different point, our equation would look different. We always simplify so that everybody's answers looks the same in slope-intercepts. So let's distribute the 1/2, add 3 to both sides. So we get y by itself equals 1/2 x plus 2.5. Okay, and just like we showed in the last example, if I'd picked this point instead of the 1, 3, or even this point, or maybe a point somewhere over here, that it wouldn't have made a difference. That even though our work would have started off differently, that once you put it in slope-intercept form, everybody should get this answer. Y equals 1/2 x plus 2.5. And if you look at our y-intercept of 2.5, it was what we thought it was. It was actually at 2.5. So even though we couldn't tell from the graph, mathematically we can figure it out.